Hello everyone and welcome back to my channel. In this video, we're going to talk about logins and users, managing access, database objects, and security. I will be using a series of scripts that you will be able to download from my GitHub page. I will provide the link on the video description. Please do remember to use the scripts on a testing environment first before proceeding to use them in production. SQL Login and SQL User. On Microsoft SQL Server, SQL Login and SQL User represent different access levels. The SQL Login is the credential that allows access to the SQL Server engine. It consists of a login name and password created in SQL Server or a Windows login composed of a Windows user or group. This could be a local or domain-based group. It is created at the server level, stored in the master database, and controls authentication. Just to show you the syntax on a T-SQL script, as you can see right here, we have to provide create login, followed by the login name. Also, we use with password, so we can provide a password. And this is an example of a strong password that you can use for your logins. The SQL user is defined within a user database. A SQL user must be linked to a SQL login in each database where access is needed. The SQL user can determine different permissions within that database, such as alter, select, insert, update, delete, execute, etc. An example of how to create a SQL user is right here. Unlike the SQL login, where we optionally specify the master database, when creating a user, we always have to specify the database in which we're going to create a user. The syntax is create user, followed by the name of the user. Then we provide for login. Now, this makes reference to the login name that we created before, and we provide the name of that login. In short, SQL login. This is the key to the main door that allows access to the SQL server. SQL user. This is the access card to the database and its contained objects. Now that we saw the script to create a login, I want to expand on a couple of options you can specify during the creation process. In this scenario, I will be showing 3 basic options you can use. There are more, but for the purpose, this should be more than well. The first option you see on the screen is default underscore database. This specifies the default database to be assigned to the login. If you don't specify this option, the default database is always set to master. Second option is check underscore expiration. This applies to SQL Server logins only. Specifies whether password expiration policy should be enforced on this login. The default value is off. Check underscore policy. Applies to SQL Server logins only. Specifies that the Windows password policies of the computer on which SQL Server is running should be enforced on this login. The default value is on. Now, let's proceed to create our login. To do that, we're going to highlight the script and execute it. You can see command was completed successfully. One way to verify the existence of the login is to use Object Explorer. Go to Security, Logins, and there it is. Now, we'll proceed to see the creation of the login using SQL Server Management Studio. We will now proceed to create the login using SQL Server Management Studio. For that, we need to have Object Explorer open. If you don't see Object Explorer in your SQL Server Management Studio, just go to the main menu option, View, and then go to Object Explorer, which is also the same as pressing F8 on your keyboard. Once there, open up Security, Logins, and right-click on Logins. Then select New Login. There are 3 ways we can create a login. One is Windows authentication, where we provide a local or domain user. Second is Microsoft Entra authentication. And the third, which is the one we're going to do, is SQL authentication. We provide the name. In this case, we're going to call it supervisor2. We'll provide the password. And we'll remove the user must change password at next login. Kind of funny because we're creating a login, not a user. Anyways, we click OK, and there is the supervisor to log in. I will now show you a SQL function called LOGINPROPERTY. Okay? LOGINPROPERTY returns information about login policy settings, and the way it works is that you use a select statement followed by LOGINPROPERTY, and then you pass on a login and a property name. For a list of all the property names that you can use and further information about the function, please visit this link right here, which I will also provide on the video notes. Now, I'm going to query supervisor 1 and supervisor 2. I'm going to ask with the function to return the number of days until the password expires. Okay, so let's execute. And as you can see, there is no specific amount of days for the password expiration on supervisor 1. But we have 42 days for the password on supervisor 2 to expire. This is because the way we specify that upon creation. The second property name we're going to see is called is must change. Now, this indicates whether the login must change its password the next time it connects. 0 is equals no and 1 equals yes. But also, this also applies to new logins that have not had access to your SQL Server. So let's run select statement, and we get 0 for both because we did not indicate on any of the logins that they must change the password on next login. So it returns 0. Otherwise, it will return 1 for yes. Last one I'm going to show you, it's called bad password time. Now, this one returns the time of the last attempt to log in with an incorrect password. Pretty useful anytime when you need to see any login trying to access your SQL Server. And in this case, there is a default value of 1900 January 1st, midnight. It's a default value because we have not logged in with the users and not on those dates. But as soon as any of the logins tries to access with the wrong password or a bad password, we'll get the date and the time when that happened. Now I will proceed to create a user on a database using a T-SQL script. I will also show you how to optionally add roles to the user. This process involves what is known as user mapping, in which we add database level roles to the user. Those roles only affect the specified database. Also, we can add server level roles to the login, which apply at the server level functionality. Please note that I will not be adding any of the roles. I only show them to you for demonstration purposes. Before you create a user on a database, you need to make sure you're on that database. That's why it's a good idea to use the use database option on the beginning of your scripts. I can have it here. Commands are create user followed by the name of the user that you want to create. And you provide for login and a login name. Optionally, you can say with default underscore schema. That way you associate schema to that user. But this is optional. You don't really need to do this. I'm just putting it for example purposes. Okay. So let's create a user. And the user has been created. There are roles that you can add to the user. And this is something I'm going to explain a little bit later. There are roles and permissions. Roles affect the database globally, meaning all of the objects will be affected. Permissions are more object specific. Okay, so I'm just going to explain them. I'm not going to apply them now. So the first role I'm going to explain to you is DB underscore data reader. This role will allow the user to read any table on that database, meaning select statements of any kind. It works for existing tables and any new tables that you create in the future. There's DB underscore data writer, which allows the user to add, delete, or change data on the tables, existing and new tables. Additionally, there's DB underscore DDL admin. Now, DB underscore DDL admin is a very dangerous one because it allows the user to execute DDL. Now, DDL stands for Data Definition Language, which means the user will be able to create, alter, drop or truncate data on any table. Okay? So you want to be careful when you assign this type of role to a user. There are other roles that you can assign. For example, server level roles. There are more roles actually, but I'll show you these in the meantime. This role is called process admin. And the reason why you will assign this role to a user is so that the user can end or kill a process that's running on SQL Server. What kind of process? Well, imagine a long running query, imagine a bulk insert that's blocking all the sessions or is not moving at all, it's suspended on the status. And you don't need to be a sysadmin to end or kill the session. So any user with that role will be able to perform that, right? So now that we're seeing this on the script level, let's see this on SQL Server Management Studio. Now we'll proceed to add a user on a database. For that, I need to go to the login sections of security, and I'm going to double click on Supervisor 2. Once there, I go to User Mapping. Then I select the database where I want to create a user. In this case, we're going to use corporate data underscore east1. Check the map box, and it will automatically create a username for me. Please bear in mind that I can change that username to anything that I want. I'm just going to leave it as is, same as the login for sanity purposes. Select on the script. I can add a schema if I wanted to. So select the schema, in this case, DPO. Click OK. There's a schema. Unlike the supervisor one, I'm going to add a role, a database role to this user. I'm going to make it db underscore data reader. That way he can read all of the tables on the database. Click OK. And since I'm using SQL Server Management Studio 21, it will expand automatically for me and will show me on the database, the security tab, the users, and as you can see, I got supervisor 2 created already there. For general and educational purposes, I'm going to show you on the screen database level roles and server level roles. First, I'm going to start with database level roles. Please pause the video to read more. Server level roles. And we're done. Now I'm going to show you how to grant permissions to a table for a specific user. In this case, we're going to use a table called sample people located on corporate data underscore east1. We right click on the table and go to properties. Let's make this a little bit bigger. There you go. Once there, you click on permissions and you search for the user. Now, the way the search works is that you either type the username or you can click on browse. If you click on browse, you'll have a list of users. Not recommended when you have thousands of users, but that's one way to do it. Let's click on supervisor 1 and then let's click OK. OK again. And there's your list of permissions that you can provide to the user, in this case, supervisor 1. There are several columns that you need to be aware of. There's the grant column, which grants the permission. There's a with grant column that allows the user to grant that specific permission to all the users. And there's the deny column. The deny column, as the name states, will deny the permission to the current user. Now, one thing about the with grant is that anything that's with grant will also be grant. Now, it means that supervisor 1 will also be able to grant this permission, in this case, delete to all the users. We don't want that. Let's also add more permissions like insert, select, and update. We can say that this user can grant select to all the users as well. It's not very harmful permission. It can be granted. And let's deny the alter permission. Once we're done with our permission selections, we can click OK. And the permissions have been granted. Another way of assigning permissions to tables is by using scripts. This gives you more control and allows you to reuse them on other users with minor changes rather than walking through the whole graphical interface all over again. Also, Beyond the security levels we have seen so far over table objects, we have a feature known as column level permissions, which provide a more granular control over data access within a table by allowing you to specify which users or roles can perform actions like select, insert, update, or delete on individual columns rather than the entire table. This is a key aspect of implementing robust security, especially when dealing with sensitive data where different users may require access to different subsets of information within the same table. A good example of using column level permissions is what you see right here on the screen. This portion of the script will allow permissions on only two columns of the sample people table to the supervisor1 user. Let's run the process, and we're ready. If you want to override that and have supervisor one access all of the columns on the table, you can just do a grant select and specify the object name and the username. Additionally, we're going to test the with grant option where supervisor one can grant access to another user for this table, hence becoming the grantor. I'm going to add all the permissions just like I added on the form. We're going to grant insert, update, delete to sample people as well. I'm going to deny the alter. And I'm also going to add select, insert, and update permissions to sample products. On this window, I have a connection with supervisor 1. I'm going to double check on that so you can see that this is the connection I have, and that is correct. The user that is connected to the session is supervisor 1 on corporate data underscore east1 database. What I'm going to do now is then I'm going to have supervisor 1 grant the select permissions on sample people to supervisor 2. So supervisor 1 is going to become the grantor, and we're going to check on the interface. Now, if we right click on the sample people table, properties, permissions, you see we have supervisor 2 already there. And if we click on supervisor 2, he has the select permission enabled, and the grantor was supervisor 1. Another way of adding security to your SQL instance or database is by the use of roles. You can use existing roles or create a new one and assign to a login or user. There are two types of roles: server level roles and database level roles. Server level roles manage permissions for the entire SQL Server instance. Database level roles control permissions within a specific database. Let's take a look at server level roles. The way to get there is by going to the security, then going to server roles. If you click on the plus sign, you'll see that there are fixed roles already created for you. They serve a specific purpose. Or you can make your own role if you want to. If you want to do that, just have to right click on server roles and say new server role. And you specify the name of the role that you want to create. For example, let's call this test server role, just for the practice. Below that, you have what is called the securables right here. On securables, for the purpose of demonstration, I'm going to click on servers. As you can see, the only server that I have is corporate data server. I'm going to click on that, and right away, it's going to show me the explicit permissions that I can add. Remember, these are server level roles, so they affect the operability of the server. Let's go very quickly through the list and see all the options that we have. As you can see, most of the options have to do with administration and altering objects on the server itself, including sessions, logins, link servers, connections to SQL, connecting to any database, and so on. For the purpose of demonstrating how this works, I'm just going to click on Create Any Database. If I want to, I can just go straight up to Members, then click on Add, and right here, I can look for logins. I'm going to click on Browse, and here's my list of logins. Make this a little bit bigger so you can have a better view. I'm going to click on supervisor 1. I'm going to click OK and OK again. Now I have a new role called test server role. If I want to, I can just click OK, or I can script all this process. Just for fun, I'm going to script this and put it in a new window so you can have it on a script in case you want to run this with a different name. Let's click OK for now. And now I have my new role. Now I'm going to show you how to create a database level role. To do that, I have to click on my database. In this case, I'm going to use corporate data underscore west1. And I have to go to security. On security, I need to be sure that I have users. In this case, I have no users on this database. So I had to create one. In this case, I'm going to create supervisor2 on that database. I don't need to provide the password because the password is already on login. All I gotta do is say create user, pass the username, and say for login, then provide the login. Just that simple. I run this. Once I refresh here on the users list, there it is, supervisor2. Okay, that is done. Now, I click on roles, then I click on the plus sign of database roles. Just like on the server roles, I have very specific roles. Those are fixed roles, but I'm going to make my own. So I'm going to right click and say new database role. Just like the previous one, I can say test role. I can go to securables, then on securables, I can do a search and say all objects of the types, obviously, and it will bring me all of the objects that are available. In this case, I'm going to select tables and say OK. Then I'm going to say that for this table, I want to give this user select, insert, and delete. And for the next table, it's going to have delete, insert, and select as well. Just click OK. And it's done. So now that it's done, I can go to the user, right click on the user, go to the properties, go to membership, and select one of the roles that I created. In this case, I have the test role right here. I click on that, click OK, and now he's a member. I can keep on adding more users if I want to, and I don't have to specify the select, insert, and delete. Let's do a quick test of the permissions that we assigned to supervisor 1. But before we do that, let's make sure we're on the right database and with the right user. And it looks like we are. Okay, so let's check the select statements for both sample products and sample people. What do you know? They work. Now let's test the update. I would like to search a record on sample people with the ID 479. And there it is. I'm going to update the first name from Peter to James. One row affected, so it means that worked. Yeah, it worked. Let's do an insert. Looks like it worked. Let's find out. Yep, it did. Now we're going to test the delete. It worked, and it should be gone from the table. Yep, it's gone. Now, we're going to do the same operation on sample products. Let me get a product ID of 83. If there's anything like that, yeah. I want to update the department, product department, from scrap to foot. Let's see if that works. And it does. Let's double check. And there it is. Now let's do an insert. According to that, it worked. Let's verify that it really worked. And there it is. Now let's test the delete. Aha, didn't work. The reason is because I haven't given supervisor 1 any delete permissions on sample products. Let me do that just now and see how it works. Okay, where you at? Where you at? Where you at? Okay. Now, this is for sample products for supervisor one. I'm going to give it a grant option. Yeah, why not? Let's try it. Let's test the permission again. It works. All permissions work on the fly. No need to sign out the user, reconnect, none of that. They just work on the fly. Now I'm going to test other objects. In this case, it's going to be a store procedure, a view, and a function. Okay, now we're going to test other objects. In this case, it's going to be a store procedure, a view, and a function. For functions and store procedures, you need to grant a permission that's called execute. For views, you grant the select permission. That's basically all you need. It's a view, it's like a select statement. So let me test that I don't have any access to these objects with supervisor one. And actually that is. It's telling me that I don't have the execute permission. If I try the view, it's going to tell me that I don't have the select permission. As for the function, I don't have the execute. So let's correct that now. Let's correct the store procedure right here. Okay. Let me run the store procedure. And there it is. Let's do the view. The view is right here. I had to grant a select permission. And there it is. Let's do the function. Let's grant the execute. And there it is. Now I'm going to proceed and show you how to revoke these permissions as well. Please stay tuned. We're going to take a look at how to revoke permissions, specifically for supervisor 1 and supervisor 2. There's different ways of doing it, even though it's the same result. You can say revoke, which is mandatory, the permission you want to revoke. Then you specify the object. In this case, it's going to be sample products, and then the user. Notice that I have object and 2 columns. This is basically optional to do, but this is to explicitly indicate that the permission is on a database object. Okay, so we're going to revoke the insert and the update for sample products on supervisor 1 user. Let's proceed. All right, that's one way to do it. And the other way is when the permission has the with grant. Now, whenever you have a permission that has a with grant, you have to do exactly the same syntax, except that you have to tell in the end, cascade as DVO. Okay, so that it deletes that permission and all the other permissions that were granted by that user. Let's proceed and revoke the select and the delete for supervisor 2 and supervisor 1. On supervisor 1, we're going to revoke the select, and on supervisor 2, we're going to revoke the delete. Let's proceed. And it's done. The following is an integral part regarding server access and security. One of the main duties for a DBA, aside from database backups, is to be able to get a list of all the logins from a SQL Server instance, since they are linked to the database users. Every login created on SQL Server has a unique ID. This is known as a security identifier, SID for short. It uses a data type of byte binary 85 for storage and is the link to each database user. There are 2 system catalog views to get login information: server_principals and SQL_logins. Server_principals is a system catalog view in SQL Server that returns a row for every server level security principal, such as SQL and Windows logins. It contains information about principals that exist at the instance level, not within a specific database, whereas SQL_logins returns similar info, but just for logins. This last one also returns the password as a hash, specifically in a byte binary 256 data type. By combining both system catalog views, you can recreate your SQL logins, which is something that can be very helpful during a disaster recovery scenario. This is also important because database do carry users and the permissions assigned at the database level, which are linked to a login with the corresponding security identifier. Let's take a quick look at server underscore principals. If we run the query, we can see that we have information about the logins, specifically Windows logins and SQL logins, as you can see right here on the square. We also get the SID and the name, the creation date, modified date, default language, and all the values. If we run SQL underscore logins, we'll also get important information. We'll also get the SID, the name, and very importantly, we get the password hash. This will help us recreate that login in another server if necessary. Here's a script to recreate your logins. Please remember that there will be a link on the video notes where you will be able to go to my GitHub page and download all of the scripts that you saw on this video. The scripts are downloadable as is. There is no warranty at all, so use them at your own risk. I'm not saying this is going to damage anything in your computer, but just be careful when you run them. Don't run them in production. Okay, so let's execute the script. As you can see, it returns on purpose some information about the user, like the SID, login name, login type, and so on. Actually, there's three important columns, which is the login name, server role, and the script. The login name, because you need to know which login name you're going to work with. The server roles, because logins sometimes, aside from the public roles, they have other roles as well. In this case, supervisor 1 has 2 additional roles, which are process admin and test server role. And also the login script. This is the column where you have the full script to create this login. I'm going to copy the one for supervisor 1, and I'm going to show you what it looks like. As it stands right now, the script to create supervisor 1 is a beautiful one-liner. Obviously, if you paste another one below that, it's going to work as well. Okay, so it's going to do one after the other. Sometimes you want to format this so that it looks a little bit better, which is a good idea, more readable. And let's do just that so you can have a better view of the final script that you're going to use. For example, this is the script to create supervisor 1. It has exactly the same password. It's hashed, so you don't have to worry about that. And you also have the same SID. This means that if we take a backup, for example, from corporate data underscore east1, which is the database where we created this user and restored it elsewhere, and then we run this very same script, we will create the login, which is going to match by the SID with the user that's created on corporate data underscore east1, and it has to work exactly the same way as it works here. Okay, so bear that in mind. If you need to back up your logins, this is the script you need to use, and just keep an eye on the server roles so you create the same server roles on the new server where you're going to create the new logins. As a final part of this video, I'm going to show you how to drop a user and drop the login from SQL Server. First thing we're going to do is run this portion of this script. What it does is connect to the corporate data underscore west1 database and verify for the supervisor to user on that database. Okay, let's run the code. And there it is. Now that we know that the user is there, we run this code here, which will verify for supervisor 2. If it's there, it will drop the user. Let's run the code. And we can double check the existence of the user on that database. Now we're going to do a similar code, and this one will do check for a login named supervisor2 on SQL Server. Let's double check on that, and there it is. This code here will drop the login. Okay, let's execute the code, and it's gone. We can double check for any logins called supervisor2 on our SQL instance, and we have none. If you have found this video to be useful for you, please leave me a like or subscribe. And if you have any additional questions regarding to the material that you just saw in this video, you can also leave me a comment and I will get back to you as soon as I can. Thank you for watching.